This presentation is about spatiotemporal diversity of Atlantic Niño and associated rainfall variability over West Africa and South America. My name is Sang-Ki Lee from NOAA AOML, and this work was led by Ignacy Valles Casanova, myself, Greg Fols, and Jose Pellegrini. Closely phase-locked with the seasonal cycle, Atlantic Niño usually develops in boreal spring, peaks in summer, and dissipates in fall. As summarized in this figure, Atlantic Niño is typically characterized by a warm sea surface temperature anomaly and positive sea surface height anomaly in the eastern equatorial Atlantic and westerly wind anomaly in the western basin. Some Atlantic Niño events are linked to increased frequency of the flooding in the West African countries and in northeastern South America. We identified 22 Atlantic Niño events that occurred during 1948 to 2019, and these longitude time maps of the equatorial Atlantic sea surface temperature anomalies averaged between 3 degrees south to 3 degrees north are derived from the 22 Atlantic Niño events. The spatiotemporal evolution patterns of these events are different in terms of their timing and amplitude of the onset and peak and dissipation. And in fact, it's difficult to find any two events that closely resemble each other. By using a spatiotemporal EOF analysis, we identified these four most frequently recurring Atlantic Niño events. They are early terminating, persistent, early onset, and late onset variabilities. Due to the difference in the timing of the onset and dissipation, they display large differences in rainfall variability over West Africa and South America. As shown in this figure, both the persistent and early onset varieties are linked to strong El Nino events during the preceding boreal winter, which suggests that they are largely forced by El Nino events. The early terminating variety is driven by a negative phase of the Atlantic meridional mode in boreal spring. The late onset variability developed through atmospheric erosion processes internal to equatorial Atlantic and shows no clear source of the external forcing in boreal spring. And this presentation is based on a recent paper published in Geophysical Research Letters. Thank you for your attention.